Hey guys, it's Ratam from FTC Team 4717, and in this video we're going to be creating parts using top-down design. We're going to be using the same skeleton sketch from before, but building upon that to create the parts of the drivetrain. So the first thing that we're going to do is insert a derived part. And the part that we're going to insert is the motor, and we're going to do this so that we can use the part to find out where we need to put the holes to mount the motor. So what we can do is click on Derived right here. You can go to Search Tools as well. Search for Derived and then find that. Actually, before that, I need to import it. So I'm going to go ahead, import it, create a composite part, and then it should show up here. It'll take a while to create a part studio, so we will be back when it is done. So as you can see here, there is a part studio here of the motor. And there's an assembly here of everything. So what we're going to do is, because this is literally just a bunch of parts put together, we can't really import the entire thing because that's an assembly, and you can import derived assemblies, I believe. So what we're going to have to do is just import this one part here, and yeah, so we can go back into our part studio and create another sketch, and for this one we'll call it the inner drive plate, and then click done. Oops. And so the first thing that I'm going to do is draw circles for the bearings for the wheels. So I know this is 0.5 inch bearing for the outer diameter, so I'm going to put that. Same thing here. Actually, I could have mirrored that, so I'm going to do that. And there we go. And one thing we're going to change is for this pull here, we're not going to use the GoBuilder ones. We're going to use a feature script in the next video, which will allow us to create an HD profile pulley with 24 teeth, because it'll be easier and we can 3D print it, and we can customize it to our needs. So we have the holes for the bearings. Next thing we need to do is insert the motor. So as a derived part, so derived, and then here we have to pick the one part. So it looks like this one would be the right one, and there we go. So now after we derive the part, we should put at the top, and then after we derive it, we need to transform it, and then we can do transform by make connectors. So we can just click which connector to transform it on. So we want the one on this plane here, so I went out here and got the center of that, and then I'm gonna mount it to right here. And then let me click this actually before, and so there we go. So we got that, and then I'm gonna do this. Oops, there we go. So that's like where the motor would be, and then we can draw off that. So we can go back to our inner drive plate sketch, and of course bring this in, and I'm going to rename this to motor. I'm going to put this after skeleton so it doesn't give any errors, because we're building something off of the skeleton. And then we can put motor transformation, and go back to inner drive plate, and then on the other side what we can do is literally just project these holes. And I'm going to make them construction projection because these are actually M3 screws. And one thing that happens is whenever you project it, it's not exactly like the size of the M3. So we can make a construction projection so it won't do anything in the extrusion. And then later we can use the hole tool to create M3 screws. So I'm going to project all 4 of these holes, and then do the same thing by mirroring on the other side. So there's that. So there we go. We have the holes for the motor, or the points, so we can create the holes for the motor, and we have the bearing holes. And that's really all we need. And we can pocket it using the vent tool later, but right now that's not the focus. So we have everything we need. Now we just need to create an outline. So what I can do here is get a corner rectangle, or even a center rectangle, and then start on the intersection point between these two lines. And then just go out like that. And we said we wanted a 17-inch drivetrain before. We can dimension this to 17 inches. And as you can see, it's coincident to the wheels basically. And then the height of the drivetrain, we might want to do like 96 millimeters exactly. So it's like, or a little bit less than 96, so maybe 92. So it doesn't touch the ground. And there we go. And then to make it look nice, we can fillet it. And then maybe 0.5 inch. So it looks a little bit better. And there we go. So that's the sketch for the plate, and that's how you use skeletons and plates together. So the next thing we can do is extrude this. So extrude, and then we can say 0.25 inch or 1/8 inch. There's that, and then new. It's a new plate. So I don't like the color, so what we can do is click on that right there. Click on this, and then we can say we want something like that maybe, or that. So there's our plate, and we have the bearing for the hole. We still don't have the bearings for the motors. I mean the holes for the motors. Another thing I'm gonna do here is rename it to inner drive plate extrude. And now we can hide this part, so we can see the holes for the sketches. And then click use the hole tool, do through, ISO, clearance, size M3, and the sketch points, we just do this, 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 and this, and then this, this, and this. And one thing we forgot to do is the churro holes. So those are 1/4 inch, I believe. So we can just use that right there, 1/4 inch, and mirror it across. So we don't have to have multiple dimensions. And there we go. And so it automatically makes the hole there because we already extruded it, and it's after we made the change. So hole 1 is not a good name for this, so we can just say motor holes. And there we go. So there's the inner plate, and then we can make the outer plate as well. So what we can do is create another plane here off of this plane that's offset, and then we can just say 1 inch for now. I don't know the exact distance of the wheels, and so we want it to be on the other side, and then we can name it outer plate plane. And so for this one, what we can do for the outer plate, since we have the inner plate, what we can do is click on sketch, project everything off of this plate except the motor holes, and so that'll be the outer plate basically. And then extrude it. And then one thing we forgot to do is add things that could connect both of the sides, like standoffs or something. So what I'm going to do is make that after I extrude the outer plate. So we can make this outer plate, and then extrude this, That's new, 0.25, there we go. Oh, not 0.25, 1/8. There we go. So that's an inch between the two. That looks a little bit small. Probably needs to be 3 inches or something. So we can change that. So we can call this outer plate extrusion. And then for the plane, the offset, what we can do is put 3 inches right here, so it looks more like where it's supposed to go. And the wheel would be right here. And something that I do want to mention is we can obviously use variables and parameterize stuff. And that's actually a lot easier. So that's something we're going to do in the future and show you guys. But for now, we're just going to change the variables inside of the tools, or the numbers inside of the tools. So the next thing we need to do is put the standoffs. And so we can put that in the inner drive plate, and so we can use the wheel as a reference to know like where we can put the standoffs, because we don't want it to hit the wheel. So right here it looks like we can do that. Let me see. So we can get the hole, we can get a circle, a construction circle, to show what the standoffs are. And standoffs are 6 millimeters, and so we can do that. And then maybe we want to put like from the top, we want to do a 1/4 inch, 0.25, and then from the side another 1/4 inch. And then we can just see really how far away we are from the, and then there should be no dimension. Actually there should, 6 millimeters. And so as you can see, it barely doesn't touch the wheel, so that's a good thing. And then we can mirror that across this line here, and I'll bring it right there. So it's barely not touching the wheel, which is perfect because it's good to have one on the top and one on the bottom. And then same thing over here. Mirror this, mirror across this plane, do that, and there we go. We might want to have more standoffs. So what I'm going to do is actually get the pattern tool, so linear pattern, and then click on that, and so it'll make a pattern of each one. So this dimension right here is how much you want each one to be apart. So something that I do is I delete this dimension actually, and after deleting the dimension, what we're gonna do is delete these right here and dimension the edges from each other, from the first and the last one. I'm not sure if I got the edge right there, but right there. Okay. So then the next thing that I want to do is I want to get the dimension from this side to this side. So I know about 17 inches, and then we know we want it 0.25 from each side. So that's 17 minus 0.25 minus 0.25 is what I want the distance to be, which is 17 minus 0.5. So we can just put that right there, and there we go. So that's literally just makes it like so much better. And then because it, like, you don't have to find out the distance, it automatically just kind of does it for you. And then we can have 7 holes maybe, and then of course before we do that, we have to dimension again from this one all the way to the end. It kind of just does the math for you. And then I want this to be 16.5, and there we go. We have 7. So the next thing we can do is just mirror this across the bottom. There we go. oops. Okay, so we have our standoff holes, and we know it's not touching anything because we have a sketch of everything that's in the blade. We know it won't touch the belt, we know it won't touch the motors or anything. So the next thing that we're going to do is, again, get the hole tool. And actually, one thing I can do um, is in this motor hole sketch, I could literally click on these, and then I can do motor holes plus standoffs. So we don't have to have another hole tool. That might become like a little um, like you want to keep your workspace clean. So okay, so we can see this one touches the wheel. So there isn't really much we can do unless we move it over. Then that won't be symmetrical, or like it won't be the equal distance. So I might just keep that for now, and then later we can change that if we want. But I think just having this many standoffs is just fine. And there we go. So I made the holes there, and then all we have to do is project on the outer plates. The same thing, project. And last two. There we go. There, okay, so we have that done. So as you can see here, we have all the holes now, and that's it. We're done creating the plates. In the next video, we're gonna have to make the pulleys and talk about multi-part part studios, and then in the video after that, we're gonna be assembling everything. So yeah, thank you guys for watching this video, and we hope you come back for the next video.